This is lesson 1.1 on recursive sequences for Algebra 2. Before we start, there's a couple things we need to define. The first is sequence. A sequence is an ordered list of numbers. So for example, 2, 5, 8, 11, ... So that's an ordered list. Now there's something called a term of a sequence. A term of a sequence is like what number in the pattern. For example, this is the first term, so it would be u sub 1. This is the second, so it would be u sub 2. This is u sub 3, u sub 4. There's something called a general term, and what we say for that is u sub n. This represents the nth term of the sequence. Okay, so a sequence is an ordered list of numbers, or like a pattern, and then the term is which number in the pattern it is. The general term is u sub n. That's what it's called. It's the nth term of the sequence. There's something called a recursive formula, and the recursive formula has two pieces. So it has u sub 1 and u sub n equals u sub n minus 1. This is the first term. And this is how you find the next term. It's basically saying if you want a term, take the one before it and do something to it. So if we think of the example that we started with, 2, 5, 8, 11, ... The first number is 2. And then the pattern, or what happens each time, is we added 3. Okay, so the pattern was to add 3. There's two types of sequences. The first one is arithmetic. That means if you add or subtract, then if the pattern is adding and subtracting, it's called arithmetic. If it's arithmetic, it has a common difference. D equals something. Okay? In this example, when we look at that, we would have u sub 1 equals u sub n equals u sub n minus 1. And we'd have whatever the first term is, who knows, and then it would be plus d, the common difference. So this is what a recursive formula looks like for an arithmetic sequence. Okay, then we have geometric sequences. Geometric sequences are when you multiply or divide. So if the pattern is multiplication or division, you have a common ratio. So you say r equals something. So with this one, what we have is u sub 1 equals u sub n equals u sub n minus 1. And then again, you have the whatever the first term is, and then it's going to be times r. So this is what a geometric sequence looks like. So this example asks us to write the recursive rule to produce the numbers in the chart. And then it looks like they want us to find the 10th term. So what we do is we always start with u sub 1, u sub n equals u sub n minus 1. The first term is 8. The first term is 8, so we go 8 right here. And then what you notice is from 8 to 2, that was a drop of 6. From 2 to negative 4, that was a drop of 6. So we're subtracting 6 every time. So we would go minus 6. In this case, d equals negative 6 because it's arithmetic. So if they ask, the difference is negative 6. Then to find the 10th term, this one, the fourth term is negative 10. So we would do negative 10 minus 6 is negative 16. Minus 6 is negative 22. So we're at 4, 5, 6. Minus 6 is negative 28. Minus 6 is negative 34. So we're at 4, 5, 6, 7, 8, 9, 10. We need to do 2 more. So minus 6 is negative 40. Minus 6 is negative 46. Okay. Then the last example here says same thing, write our recursive rule. So u sub n equals u sub n minus 1. Our first term in this one is 400. And then the pattern, this one's a little less clear. So what I tell students and what I'd like you guys to do is if it isn't addition, because this is clearly like subtracting by a couple hundred, and this is not the same amount. So what you should do is start dividing the last number in the list by the one before it. 25.6 divided by 64. And that equals 0.4. Then do it again. 64 divided by the one before it. Is 0.4. So we keep getting 0.4. That means R equals 0.4. So we'll multiply by 0.4. And then if we wanted to find the 10th, we would just take 25.6 times 0.4. That's the 4th term, 5th term, 6, 7, 8, 9, 10, 0.042. All right. And then the last one. So this says the week of February 14th, the owner of Nichols Appliances stocks hundreds of red heart-shaped vacuum cleaners. The next week he still has hundreds of vacuums. He tells the manager, discount the price 25% each week until they're gone. So if you get a 25% discount, that means you still pay 75%. So to convert that to a decimal, you divide by 100 and you get 0.75. This is your R. Okay? So part A says on Valentine's Day, each vacuum was $80. What's the price the next week? So what we would do is we would take 80 times 0.75 and we get 60. So $60 is how much they would cost the next week. Technically, 80 is going to be U sub 0. In class, we did the notes a little bit differently, so they'll have different numbers. But U sub 0 is like the beginning of time. Nothing has happened. They were $80. U sub 1 is 1 week later. They're $60. We need to find the price in the 4th week. So U sub 2, we would take 60 times 0.75. And we get 45. So in week 2, they're $45. Then we go 45 times 0.75. And we get $33.75. And then U sub 4 is going to be 33.75 times 0.75, which is $25.31. So they will cost $25.31. So we know in week 4, it is $25. Part C says, when will the vacuum sell for less than $10? So we can take this times 0.75. This is week 5, week 6, 7, 8. So in week 8, they're $8.01. So during week 8, U sub 8. You guys have an assignment. It's worksheet 1.1. Let me know if you have questions, okay?